I'm not an engineer. So you may be asking me, why is he talking about loads? But I'm not going to talk about those mathematical things, all those things. But I'm going to give you some knowledge about things you should know, because when you go and ask for somebody to build a greenhouse, they're going to tell you this is going to take this much load. They'll give probably this many kilograms per square or pounds per square feet, whatever that is. You need to know what they're talking at least, isn't it? What are they talking about? What do you mean by live load? What are they talking about it? What is a dead load? What do they mean? Because once you get a design, all these terms are there in the design. So I'm going to explain what do they mean, why they're important. Okay? So that way, when you are having a conversation with a greenhouse manufacturer, you at least know what they're talking. So you're in much better place to negotiate with them. That's the reason for this chapter. Okay? And then we'll also talk a little bit about those coverings, the polyethylene glass type coverings, and what are the pros and cons, advantage, disadvantage, things like that. That's what we're going to deal in this chapter. 3 things: designs, loads, coverings. 3 things. Okay? A little bit technical chapter, not much, but it's still easy. Okay? But important, very important. All right. So if you look at greenhouses, again, what is this greenhouse? Is it no? But what is it? Single span or multi span? It's a single span, right? We're going to look at designs for both single span and multi span separately. So we're now looking at the designs for single span. There are so many designs, but the two standard ones are an arch style and a gable style. Okay, 2 standard ones: arch and a gable. Arch is arch, isn't it? Gable is more like an A-frame. Okay. Now there are certain elements, structural elements, and I'm going to tell their names because you may see all these names in the design. So what you should know. Now, by the way, you already know ridge vent, don't you? We know the ridge vent right there. There's a green ridge vent there. You know that, easy. Okay. Does this greenhouse has a ridge vent? No, it does not. Okay, but that one has. You can actually have here too, but I did not put it there. Okay. All right. The second thing I want you to tell you is about 2 things: purlins and rafters. Purlins and rafters. Okay. So what is a purlin? What is a rafter? I'm going to explain on this. The dark black lines here, you see those lines? Those are rafters. They hold the weight of the glazing material. These lighter lines going like this, those are purlins. So let's say you have a glass greenhouse or a polycarbonate or even polyethylene greenhouse. You have to connect that material to the greenhouse roof, isn't it? So you put some screws, bolts to tighten them. You use purlins for that. The glazing material or the covering material is connected to the greenhouse on purlins. Okay, screws and bolts are connected to the purlins. That's why purlins are meant for. Rafters for weight, purlins for holding the glazing material. So at least now you know what those 2 things. Understand now? Rafters and purlins, 2 things. Okay. Side posts. These are side posts. Go vertical like this. So if you have a greenhouse like this, you put posts, right? 1, 2, 3. These posts are taking the weight of the roof. They're bringing down to the foundation. Right? Those are called side posts. If you want to grow plants like tomatoes and pepper, vine crops which are tall, what is the recommendation for side posts? They should be small or long? They should be tall, right? 14 feet minimum side posts, because those side posts determine the gutter height. That is the gutter. Well, you'll see what gutter exactly is when you talk about a multi-span greenhouse. But the side posts should be tall, so you can hang, your vine crops. All right. So that's a side post. Easy, right? Not many greenhouses use a curtain wall. Curtain wall is nothing but that short brick wall that goes around the greenhouse. Not many do that. I've not seen it. Some do that, but that is the brick wall. That's called curtain wall. Okay. Then the remaining ones, cords, struts, diagonals, these are the structural support elements. You see there? So in order to hold the weight of the roof, you need some structural elements like cords, and right? So you can see top cord is right there, bottom cord is right there, and you also have diagonals. Now look at here. The major difference between this arch style and the gable style is, in gable style is mostly recommended for what? Polyethylene or glass? That's for glass or polycarbonate. Why do you recommend polyethylene here? Because you can easily curve it, right? And compare the weight. Polyethylene is less weight compared to glass or polycarbonate. When your roofing material is having less weight, your design should also be lighter. If somebody comes and says, oh, use this greenhouse and put polyethylene, you should be telling them, why should I even invest in such a heavy greenhouse when I'm putting a polyethylene sheet on top of it? It doesn't make sense. For polyethylene, they use a much lighter structure. You see their simple side post, there is an arch there, and maybe just a little bit support here. You see, right, diagonals. But here you have cords and struts and things like that to hold the structure. Okay, so the type of structure you decide will depend on what? On the material that you are going to use to cover the greenhouse. For polyethylene, lighter greenhouse, arch style. For other glass and polycarbonate, which are a little bit heavier, you go for more like gable style. Okay, so these are the different terms they use in the design. I want you to remember again, ridge vents, all of you know ridge vents, purlins and rafters. Okay, and then side posts, curtain walls, cards and struts and diagonals for support.
So the curtain wall is around the whole greenhouse or specific?
It's usually on all sides. Okay, and the front side is more like they have more masonry there. The curtain wall is usually about 3 feet. But you don't have to go. It is only meant for some structural. If you want, if you have a, usually what they do is they put these side posts. Recommendation is dig 6 feet deep. Put some concrete first, then put the side posts. Put the anchor posts. Screw them up nice. Leave them for 2-3 weeks so it gets solidified. Then you put side posts on those anchors, right? So you kind of deep dig here. You don't need that curtain wall. Sorry. But some people do that. It's actually more useful if you're in a colder climate. So it kind of prevents that wind to get inside from ground and from the surrounding areas, because the thermal insulation is much higher for curtain wall than a polyethylene sheet. So they use that, but it's not common. Don't worry about that. Okay. But again, I want you to differentiate two major structures. Some of the names that I told you belong to structural components. And also I want you to differentiate what type of structure is required for polyethylene versus glass, heavier things. Right? Much lighter structure, lot less supports because the weight itself is light here, much more heavier structure, much more investment there, less investment here. Okay, it costs less, it costs more. Okay, now let's look at a multi-span greenhouse. Okay, what is this? This is a multi-span greenhouse. There are 3 bays. You can have 3, you can have 20, doesn't matter. Just put an example there. This is called a Venlo stair. Venlo, V-E-N-L-O. Venlo is a city in the Netherlands. It is pretty close to Germany. I think I told you this on the first day. But what happened was during World War II, this city was completely destroyed by Germany because of its closeness. In fact, Netherlands was occupied by Germany. France was occupied by Germany. But when they destroyed it, and after the World War, people wanted to grow food. And Netherlands is in a cold area. They get a lot of snow winters. So they wanted to grow tomatoes and peppers, and they wanted to design greenhouse. They started designing, but this was one that they worked very well for them. It's called Venlo style. That's the reason why it's Venlo style. And this is also what is we use a lot in the northern latitudes in India. It's a very expensive greenhouse. It's a tall greenhouse. You can see it's a pretty tall greenhouse. Okay. The profile is low, meaning the bays are not that wide. It's just probably 15 feet. Okay, small bays, not like wide bays. Like in that arch tail is a wide bay, 30 feet wide. These are probably 10-15 feet, low profile ones. Multiple bays. Okay, this is covered by what? Polyethylene? No, glass. You go for glass. It's a heavy structure. You use a Warren truss. You see that is called a Warren truss. Truss is something that provides support to your structure. In fact, even this building, I don't know if they probably, if it is a slab, you may not find it. But usually they provide, in the olden houses, they used to do that, right, with wood. So there is a Warren truss, and that's how it looks. This Warren truss is there every certain, is right there. Another one, there'll be another one, there'll be another one. These Warren truss provides the support to the entire roof. Okay, it's a tall greenhouse covered by glass. It can have ridge vent at the top. Okay, it's built with Warren truss. It's got a low profile ridges, right? Low profile base, right? Smaller ones, not wider ones, smaller ones. Okay. And the nice thing about this is what we recommend for crops like tomatoes and peppers and anything like cucumbers, even small watermelons we grow sometimes. Tall vine crops, you want to use this Venlo design. Okay, multi-span design number one, Venlo style. Okay, this is closest to what single span design. The Venlo style is a multi-span greenhouse. This design is similar to what design for single span greenhouses? Arch or gable? It is close to that one. It's just that the gable has a very high wide and shorter. Okay, whereas Venlo is multiple, sort of like multiple gables, but with a shorter, low profile greenhouses, much taller greenhouses. Okay, yeah.
When you visited to see the greenhouse in the nearby region, there was this greenhouse which was an arch style greenhouse, and the ridges were both like they were joined in the middle, and the ridges were facing each other on the opposite side.
Like this way.
Yeah, one ridge was like this. The natural ventilator.
Poly houses. Those are poly houses. There are naturally ventilated poly houses. You can also have a if it is a if it is sort of like a gable but with natural ventilation ridgement, they look more like a sawtooth, right? They look like sawtooth. Is it a single span or multi span? Whatever you saw, it's a single span. Or it's a multi span. So they were like this, right?
They were like this, and the ridges were like this, both facing the same direction.
Oh, one was like this, the other was like this.
Yes, yes.
I see. I see.
So what benefit that might be bringing? Because I think that is blocking the other one.
I'm suspecting that there may be ridges and so again, let me go back. It was more like this, but you're saying that there is a ridge here on this side. See, in an arch style, you can have two ridge vents. Ma'am, I'm thank you all for agreeing to it. I appreciate that. Okay. So going back to your question, right? So in an arch style, look at this. This is the central ridge, right? That one. That's a central ridge, right? You can have a ridge vent on this side. You can have ridge vent on that side too. Both sides can be opened up like a butterfly wing. You can close them, or you can open. When they open, it looks like a butterfly. There's a greenhouse here, but then the ridge is open. They look like a butterfly wing, right? In the middle is the ridge. So those guys may have opened for one side here and for the other on the other side. They are permanent. Okay. The other reason for that is this. The other reason is okay. So they're multi-span. We get it. The other reason why they do that is like this is again. Remember it's a ridge, right? Why do you want a ridge for? It's for ventilation. And remember that the theory I told you, when the wind blows on this side, what does it create on this side? A low pressure, negative pressure. So it pulls the hot air outside. Now, if that is the case, you should always keep this ridge open on, this is the windward and this is the leeward side, isn't it? So on the leeward side. But if you are in a region where you don't know which direction is wind coming, it could be windward, it could be leeward, depending on the season. Which is your best shot? You have some greenhouses open this way, some greenhouses open this way. That way, whether the wind is coming this way, it does some ventilation. If it is coming this way, it does some ventilation. Right? That's the reason why some designs are like that. They open on both sides, just take a chance. Right? Wind could come in any direction. That's what it is meant for. Okay? But usually they are like that, open like that. But it can also be the other way. Okay? Any case, does it answer your question?
Yes, sir.
Yep. Yeah. Okay. We talked about this. Now let's go to this one. This is also what? What type of greenhouse? A multi-span. But this looks more like what? Arch, doesn't it? That's what we call gable style. Okay? Gutter connected greenhouse. Now here is the black line, dark black line. That's called a gutter. What is a gutter? Rainwater. No, it collects rain. So it's outside. It's outside. So rainwater is falling on the roof and it has to fall somewhere, right? So they simply put a channel, a metal channel. It collects the rainwater, comes down. That's called a gutter. Okay, those are called gutters. But they are connected by gutters, so that's why it's called a gutter connected greenhouse. That's all it is. But it's most likely it looks like what? Your arch stair. Same low, investment, very little structural support. You cover it with what? What material? Polyethylene, right? Similar situation. It's also not height wise, it's just similar to that arch style. It's not tall one. So these are different. And in this case, you can have a ridge ventilation. Ridge ventilation on both sides, which will look like a butterfly opening. Okay? Or it can be just one side. Just one side. What you saw probably was a one-sided one, but they were kind of alternating on both sides. Okay? And that may be called a sawtooth or a polyhouse, whatever you call it. But this is the basic design. It's a basic design. Okay, gutter connected greenhouse. Okay, so those are the two types. Two types for single span, two types for multi-span, and there are some variations within that. You can do whatever you want, but these are the two standard types. Arch and gable.
So it is basically a modified arch type.
Possible, yeah, that's all it is. Just to create that ventilation, ridge ventilation. I mean, even this can be. All I'm trying to say is, you see, that's the ridge, right? You open that side a little bit, that's what you're looking at, same greenhouse, okay? But the standard design is this. You can create a ridge vent and make it look like an opening at the top like that.
Is it fan and pad?
You can put a fan and pad, you can just put a natural ventilation, you can roll up on the sides, on both sides, depending on where you are, okay? This can get pretty hard if they're not, at least you should use an exhaust fan. If not a pad, you should at least use an exhaust fan to get the hot air out. Right? Because natural ventilation depends on what? Natural ventilation depends on wind. And if you don't have wind, it can get too hot inside this. Okay? But these are the basic designs. Two basic designs for multi-span, two basic designs for single span. And you have some modifications from those. All right. We talked about this, so we don't have to worry about it. Let me move on. Now, I want to talk about another kind of technical word called angle of incidence. Okay? You may have heard this in your geometry, but angle of incidence related to light. That's what I'm talking about. Angle of incidence related to light. Okay? And that is very, very important. You see here, angle of incidence versus amount of light that is reflected back from greenhouse. So light comes, right? And the light, you want that light to go into the greenhouse. So plants get that light. But if that light doesn't go into the greenhouse and it's reflected back, then there's no value, right? So this is the relationship between amount of reflectance, amount of the light that gets reflected versus angle of incidence. What is this graph telling you? As the angle of incidence is increasing, what's happening to reflection? It's increasing, and there is a point where right around 30, that's the angle of incidence, that reflection increases exponentially. Initially, it's a slow increase. After the angle of incidence is more than 30, it exponentially goes up. This is why angle of incidence is so important. Angle of incidence of light into the greenhouse. So what affects that angle of incidence? The roof angle. If you have a flat roof versus a slopy roof, that's going to affect your angle of incidence. And that's what we are learning now. As you increase the angle of incidence, you are, by design, letting more light reflect back. It's a very important thing that you should keep in mind when designing a greenhouse roof. Okay? So that's why I don't know why it came back here. So let's go back. Now let's talk about what is that angle of incidence. Okay? I want you to imagine this. This is going to be a little bit difficult, but I want you to imagine this. That black line, the dark black line, imagine that as the roof. That roof, roof line, okay? Roof has two lines, right? That's one line, is another line. It's going to be even complicated for an arch. Arch is not a straight line. But imagine for simplicity, that's the black line is the roof line. I'm not showing it an angle, I'm showing it horizontally for you. Okay, that black line is the roof, but I'm not showing like this, I'm showing it like this, okay? And here is the incident light, brown line. Okay, the reflected light, that's the reflected light, and then that's the transmitted light into the greenhouse. Three things: incident light, reflected light, transmitted light. Now the angle of incidence is the angle between the incident light and the perpendicular to that roof. That's the reason why I put it like this, so to show you the perpendicular line. But it is like this, and perpendicular to roof will be like this, and light is sitting like that, and that is the angle I'm talking about. But I want you to imagine that this is the roof, okay? This is your roof, but I'm not showing like this, I'm showing it like this. The angle of incidence is the angle between incident light and the perpendicular down to the roof. Anyone has difficulty in understanding this? This is a complicated thing, little bit complicated for some of you, but I don't mind explaining one more time. It is the angle between incident light and the perpendicular line drawn to the roof. That is called angle of incidence. Okay, so if the angle of incidence is increasing, okay, what does it mean? This is fixed, right? Because the roof is fixed, that is also fixed. That means the incident light is becoming bending like that. If the incident light is coming straight, like so, let's say this is your roof, and if light is right at 90-degree angle, there is no angle there, zero, because it's right to the perpendicular. But if the light is coming at a low angle, then angle of incidence increases. When will light come at a low angle? Which season? In winter. In winter months. So your angle of incidence goes higher and higher in winter and becomes smaller and smaller in summer, regardless of where you are located. But depending on your latitude also, it can be even higher in summer also. Okay, depending on where you are. And that is why it is so important. So roof angle, the term for that is roof pitch or roof angle, is so important. So you can get away from that problem. Let's say you are in Srinagar, Kashmir area, where winters are cold, sunlight is coming at low angle, but you have a greenhouse, you want to maximize light getting into the greenhouse. You can change the roof pitch, roof angle, and get more light into the greenhouse. That is the advantage of this one. I'm going to explain that in the next slide. Okay, so generally, you see here, there is a 12 feet wide, just an example. This is actually 24 feet, but half of that is 12 feet up to here, up to the center. This is 12 feet here and 4 feet raise in this greenhouse. But in this greenhouse, it's the same width, 12 feet up to here and 12 feet up to here, 24. But what is the raise here? It's say. So in these two examples, this one will increase angle of incidence, this one will decrease the angle of incidence. The higher the pitch, in this case, more slopey the roof is, this is less slope, this is more slope, right? The more the roof slope is, the less the angle of incidence. Okay, that's the reason why in those areas we recommend a higher pitch. Roof should be at a higher pitch rather than much wider, lower pitch. Already sunlight is less in winter, and you further make a very wide with a, you see the raise here. The raise is only 4 for a 12 feet length, but here the raise is 6 for a 12 feet length. So it is much more steeper here. This increases more light to penetrate into the greenhouse. Okay, does it make sense how the roof pitch increases light transmission? You want a roof with a increased angle, not like a wider one, but more like a steeper one to get more light into the greenhouse. Okay, and the common recommendation is 6:12, by the way, remember that, 6:12, depending on whatever it is, you want to go for 6:12. Okay, a low profile Venlo style has 6:12 maybe, but the other one, gable style with high profile, may not have that 6:12. Remember that, right? 6:12, 6 for this and 12 for this. But again, let's say if your greenhouse is much more wider, then you want to even have a taller. Rather than 6, you may want to go for 10 feet raise, something like that, to create that sharp slope, and so you allow more light to get inside. Okay. Roof pitch also plays an important role. Light transmission is a critical thing, and we are talking all these design features to maximize light transmission. It's a critical thing in greenhouses. No light, no growth, right? More light, better growth. More uniform light distribution, even better growth. We are doing all these design things just to maximize that light intensity transmission and also make sure that the distribution is uniform. Right? Roof pitch, angle of incidence, all of these are very, very important.
Can you explain it?
One more time. Yeah, sure. So you're seeing two greenhouses. Which greenhouse you think has got more slopey roof? This one or that one? Right. I want you to look at that angle. You see that angle that is making? Which here, think about the angle here and think of the angle here. Where is the angle more? Right one, right? Because of that angle, the roof is becoming more sloped. When you have a slopey roof like that, that has a higher pitch. That means it's got a higher pitch. And when you have a higher pitch, more light transmits. Okay, you can go back to your dorms or rooms and actually calculate angle of incidence for this and this, and you will see that angle of incidence is more here than here, and that's what I'm showing you. By the way, I'm showing an example right here. You see here the same pitch, there's a steep pitch here and a much wider greenhouse here, right? Low pitch is lower here, pitch is more here. Now you see the angle of incidence, it is 45 for this, and here the angle of incidence is only 30 for this. What happens if the angle of incidence increases to light transmission? Reflection goes up, right? So which means transmission goes down. So you see here there is more transmission in this greenhouse, less transmission. That's what that pitch is so important. Okay, 6:12 is the recommendation. It can be any multipliers of 6:12. You can have but the ratio is important. Six units raise for a half. So you're not looking at the total width of the greenhouse. You're only looking at half of the width of the greenhouse. For the half length, you should have the 12 feet length, you will have 6 feet raise. That is called 6:12. Okay? That's the importance of roof pitch. All right. Okay, moving on. We're doing it very fast today, but I'm going to revise one more time. So we looked at, when we started this chapter, the idea was to look at, light transmission. We learned about angle of incidence, roof pitch. We looked at the designs. Now look at an arch versus a gable. The advantage of gable is you get more light transmission, right, to begin with. That's one of the best advantages, the gable, because you can now control roof pitch and things like that. But we looked at gable style, arch style. We looked at a Venlo style and also a gutter connected arch style designs for multi-span, right? And then we looked at how to maximize light intensity by modifying roof angle or roof pitch. 6:12 is the recommendation. Higher the pitch, more transmission, because angle of incidence is less. Okay, those kind of technical things are very, very important in decision making. They will have a permanent effect on your greenhouse. If you already put your money onto it and made mistakes, you can't change it. You have to reinvest and change the roof. It can cost a lot. So before you invest on anything, knowing this is important. That is the only purpose of this lecture. Okay, we give this lecture to a lot of greenhouse growers, those who are interested in this business in the future. So having this knowledge upfront is so important for them, so they make right decisions. Okay, all right. After that, we're going to go to some of the structural loads. There are 4 types of loads. The first one is called a dead load, with a letter capital D, dead load. Okay, this is, again, keep in mind, this is your structure, right? Kind of like a cartoon here. This is your structure. What's happening? That structural elements are supporting the roof, right? The weight of the roof is falling on these structural elements. The weight of the structural, like struts and cards, is falling on the side posts, and then the weight of the side post is transmitted to your foundation. That's how the weight is distributed. Okay, it's not just staying there, it's kind of being distributed downwards. So the glazing material adds weight onto the struts and cards, which add weight onto the rafters and eventually onto the side posts and eventually to the concrete. The weight gets distributed. Okay, dead load refers to all the weight load of the components of the greenhouse. It includes the permanent things. What are the permanent things? Start with polyethylene covering, or I know polyethylene is not totally permanent. In 3-4 years you change it, but we consider glazing, then the rafters and purlins. It also includes the weight of the fans, the lights, everything that is permanent, that is coming down to your foundation. That's permanent weight load coming onto that. Okay, that is called dead load. Okay, this is very, very important for wind. If the wind velocity is more than the dead load, the structure will blow away. Okay, and you will see in some cases, oh, the house is blown away by the wind. Why? Because the dead load is less than the wind velocity. Okay, that's very, very important. Okay, these are the permanent components. They add the weight, this permanent weight onto the concrete. That's what is called dead load. Okay. Now you can get calculation. You can get the weights of everything and calculate how much weight is per square feet area. But if you don't know that, there is an assumption you can make: 5 pounds per square feet. So now that pounds may be confusing to you, right? Pounds means 2.2 pounds make 1 kilogram approximately. Okay, 2.2 pounds make a kilogram. That means, and then it is in square feet. You can convert it to square meters also if you want to, but it's very easy conversion afterwards. We recommend at least 5 pounds per square feet. 5 pounds would be approximately 2.8 kilograms, something like that, 2.8 kilograms per square feet area. But in 1 meter square, you have 10.78 square feet. I'm just doing the math quickly for you. So that number translates to approximately 25 kilograms approximately per meter square. Okay, about 5 pounds per square feet is approximately close to 25 kilograms per meter square. That is the amount you're allowed. Okay, that you should put. Okay, approximately that is the weight. That much weight should be there. This many kilograms should be coming down per meter square area. That is the minimum requirement we ask for. The structure that you buy, this is very important because the companies will make a lot of money when they give you cheap material. The galvanized steel that they use, there's some specifications for that. And if you're not paying attention to that, you should ask them, okay, what is the dead load of this material? And if it is not in that range, 25 kilograms per meter square or 5 pounds per square feet, you are creating a structure that can be easily blown by sometimes by wind. That's how important that number is. Okay, the load should be that much, at least to hold your structure in place. The companies always wants to give you some less thicker material. They say, we are using anchors and bolts here that hold on to it. I will say this, even those bolts have a lifespan. If the bolts that you use to anchor your structure is a cheap quality, they'll start rusting after the second or third year because you get rain and wind and snow every day, isn't it? So in 2 years they start rusting, and what happens to a rusted bolt? It breaks and your greenhouse falls. It's a very, very important thing. This is what you have to put all of your time and effort, because this is your money. Okay, dead load. It's like building a strong house, and if your contractor is not doing it for you, you want to make sure that you get it right, because he's gone after that. You are left with your house, right? So that's what dead load is. 5 pounds per square feet or 25 kilograms approximately per meter square. That is the minimum weight you should ask for. The guy will tell you this is the dead load of your structure, and you should now look at, okay, this looks like a light load or heavy load. What I'm telling you is that if you are going to use good material, strong material, that material should put at least 25 kilograms per meter square weight onto your concrete weight. That's what I'm trying to say. Load, weight. If you're not even getting that much, then your structure is a very light structure.
How to examine this example?
Yeah. So how does that? I mean that they'll cheat you, or well, they will bring in. So look at the pipe, galvanized pipe. Okay, it can be heavy, it can be light. So when the greenhouse engineer brings you the layout, floor plan, and design, you should ask for load specifications. And in the load specifications, they will mention the dead load, D value. Look at that number. That will tell what type of material they are putting in there, isn't it? We want you to keep that number in mind. Assume a value of 5 pounds per square feet, or you can convert pounds to kilograms and square feet to meter square. That is what the units you get. But at a minimum, it should be that's what we're recommending. Okay, 5 pounds. This is a very important thing. Okay, This is where companies make a lot of money, by giving you some cheap material, and you look, it's wonderful greenhouse, 3-4 months later it's blown away, it's gone. But that load also includes, in case if you're putting some fans, things like, everything is included in that. Okay. All right, the next one is called live load. Opposite to dead load is live load, right? Live load, I'm giving you some examples. What is this guy? He's up at the top of the greenhouse. He's doing repair, right? He's standing on the greenhouse. He's putting his weight onto the greenhouse, right? What we call point weight. At one point, he's putting weight. He's probably 80 kilograms, 100 kilograms, who knows, in weight. But he's adding that weight, isn't it? So your structure should also be able to hold his weight, isn't it, when they stand on that. Sometimes what are these? Hanging baskets. Sometimes you have tomato plants hung up to that one. Right? This is a live plant material, live plants, and they also add weight. So now it's just not that 5 pounds per square feet. You have to now also include that your structure should be able to hold these things also, right? So for that, we add another 15 pounds per square feet. So 5 plus 15, already we got how much weight? 20 pounds per square feet so far. It's not there yet. We have 2 more things. So hold on. Whenever you make negotiations with your company, this is very important, right? They may give you a structure and go away, but you need to make sure that, is this structure going to hold the permanent weight of the greenhouse? Is this structure going to hold people working on the top? Is this structure going to hold those hanging baskets? Are tomato plants hung to the roof? Is it strong enough? For that, so far we came to 15 plus 5, 20 pounds per square feet. We'll convert towards the end. Okay, that's up to that. What is the third load? The third load is snow. It may not be a problem for you. How many of you probably can get snow up here a little bit, isn't it? You do get snow, right? So there is also a snow load. I will keep it minimum because not many people will experience snow. But what happens is, look at this. Just 3 inches of snow. 3 inches would be what? 10 centimeters less than that. 9 centimeters. About that much. 3 inches of snow on a roof can add 5 pounds per square feet. Okay? That's like 6 to 8 tons of weight on the entire greenhouse. So snow is not like water, it's heavy. If the snow falls on your greenhouse, it's going to stay there for some days, isn't it? Until it melts. And as it is melting, the weight of the snow is where? On the gutter, in the middle. You see more weight here, less weight on the sides. But I'm just giving you a number here. If you are in an area where snowfall is there, and the snow sits on that greenhouse for, let's say, 1 week, each day it is adding 6 to 8 tons in that 30 by 100 feet greenhouse on top of that. That's how heavy it is. And your greenhouse should be able to hold it now, isn't it? Otherwise, it collapses. So snow load is important for those regions where snow is common. Even if it snows for, let's say, 1 time in the entire year, and if the snow stays for maybe 3, 4, 5 days, you have to consider this. And for that, we ask you to add another 15 to 30 PSI. So 5 for dead, 15 for live load, and here is another 15 for snow load. That's 20 plus 15, 35 PSI, pounds per square feet so far, the weight, load requirement. We consider 3 factors. There's one last one. We'll get to that. That's probably common everywhere. But snow load is also important. Okay. Now, if you have a heated greenhouse, if you have heating inside greenhouse, unit heaters, things like that I've described, whenever it snows, you can increase the heat inside the greenhouse. And what does that do to snow? It melts the snow, and the snow becomes water, runs through gutters. But if you don't have a heated greenhouse, there is no way to escape unless you go to the top of the greenhouse and shovel it away. If you have a multi-span greenhouse, how much time and labor it takes on that cold weather to shovel all of the greenhouse? No way it is possible. Your structure has to bear the weight. That's the only way. And for that, we recommend at a minimum 15 PSI for snow loads. Okay. So dead load, everybody understand dead load? It's a permanent structure, right? Glazing material, roofing material, everything. Then there is live load, people working, plants hung to this. These are kind of like at one point. And then now we have snow load. These three things already. And the fourth one, can anybody expect what the fourth one is? Well, kind of rain and snow. Rain will go away, so it probably won't add a lot of weight on it. It falls. Something that stays for some time is what the load is about, right? Rain falls, but it flows away. But what's the fourth thing that's constantly hitting the greenhouses?
Pressure.
Atmospheric pressure. Wherever you are on the globe, it's a little bit different. But there's another big thing that hits the greenhouse all the time. Wind. Wind load is important because that's what blows your greenhouse away, right? And so we get to the wind. And with the wind, it's complicated. And these arrows kind of tell you. Wind can come from any direction. Okay? If the wind is coming this direction, all right, it creates a negative pressure on this side. You know that. And if the structure is not holding, the dead load is less, it can blow over the structure like that. Okay, bless you. But let's say you open this door by mistake and the wind got into the structure, it lifts the structure up. That's also possible, isn't it? Lifting, turning it upside down, all of this is possible with wind. Okay? Wind lift, which means the force of the wind, should not be more than 2/3 of the dead load in your area. Let's say your area gets 15 kilometers per hour. You can calculate wind lift from that, and from that you can calculate the dead load requirement. What I'm saying is that your dead load, the permanent weight of the structure, should be more than that wind lift. The wind lift should never be more than 2/3 of the dead load. Otherwise, your structure is blown away, permanently blown away. The live load happens when people are up there or you're hanging plants. Snow happens when there is snow on top of the plants. But the dead load is important because the wind is hitting that, and the wind speed should not be able to take the structure off, and for that, that is a requirement. Okay? And so for wind, we add another 10 psf at a minimum. The 10 psf will take care of 70 to 80 kilometers per hour winds also. The structure can hold it. So 4, right, altogether. Dead load, I said 5 psf.
15, sir.
Dead load 5, live load 15 minimum. Snow load is another 15, right? So that's 35, and I'm adding another 5 for wind or 10 for wind. This 45 psf. If you have Google, you can convert psf, pounds per square feet, to kilograms per meter square. It's very easy conversion. But I'm talking about 40 to 45 pounds per square feet. If a structure can't withstand this much, there are chances that your structure may be blown by wind, crushed by snow, or when somebody is standing up, it may crush down. That is the importance of this. So important. Okay? When you are designing a greenhouse, you should make sure that the structure can hold up to 45 psf. Ask the engineer to come up with that. He may say, oh, it's going to cost, but don't compensate on that. Don't say, I don't want to pay more. Okay, give me some cheaper one. You will end up with problems. Build your house strong. Build your house strong. The house should be able to hold, because your life matters. Just like that, build your greenhouse strong. It comes for a very long time. Okay, so that's why it is important. The thing is, this is not. I did not give you any formula. I did not give you any calculations here, but I just told you what these loads are, what do they mean, why they are important, and what numbers you should remember. That's all. So now you are at a position to negotiate with your greenhouse manufacturer. If he comes and says dead load and you don't know anything about it, say, okay, good, very good. He comes and says the dead load is 1 psf. Oh, very nice. But now you know it's less. It should be at least 5. Okay? All right, that makes sense, this load thing, overall load thing. All right. I think there's one last section I should be able to finish in 5-6 minutes here, or less than that. This is about covers, polyethylene covers. So there, I'm sorry, not all kinds of covers. So there are 3 standard ones, right? Polyethylene is one material used to cover greenhouses. Polycarbonate is the second one, and glass is the third one. There are 3 categories. These are the standard ones that used to cover a greenhouse. This is called glazing material, covering material, whatever you call it. This is the one that is standing in between outside environment and inside greenhouse plants. So important. This is what creates protection for plants. Okay? And there are 3 types of materials, and I'm kind of giving you certain important information. Again, you can see this is polyethylene. Okay? Polycarbonate, glass. You can see that, right? Pictures. But let's start with the classification. NGMA stands for National Greenhouse Manufacturers Association. That's what we find in the United States. Don't worry about that. You don't have it in, probably you don't have it, or maybe you have it. I do not know. But that number is not at all important. What is important is the price. Okay, this price may also vary depending on where you are. If you are importing this material from Israel or some other countries, it may be much higher than those numbers. But I'm just giving you, I want you to remember that polyethylene is the cheapest. Polyethylene is the cheapest plastic. This is in between, but glass is most expensive. When you pay more, you also get more. You get more life, more durability. That's what we call. Durability means longer life. So now you can look at durability. Glass comes at least for 25 years. This is about 10 years intermediate. Polyethylene is 3 to 5. You get remove, throw it away, and put another new one. Okay? Light transmission, good for polyethylene, not so good for polycarbonate. This number can be even higher for glass. But 90, I would say this can be little lower, 85% for polyethylene, 85, about 75 to 80, 90 for glass. So glass, you put more money, it gives you more life, but also it gives you a lot more light transmission. This is the reason why Venlo style greenhouses are covered with glass, because crops like tomatoes, peppers, they need a lot of light. 20 moles sometimes, 20 moles per meter square per day. So if you put a polyethylene, it reduces the light transmission, or polycarbonate, it reduces light transmission. That's the reason why we want you to put glass. Okay. Thermal transmission is probably not a big factor unless you are in a really cold environment. But what I'm trying to say here is that polyethylene, if you heat greenhouse covered with polyethylene, that greenhouse loses heat quickly compared to either glass or polycarbonate. Polyethylene has a very high thermal transmission, 0.18 versus pretty much nothing for polycarbonate, pretty small number for glass. Compared to those, this number is much bigger. And that's the reason why a greenhouse covered with a polyethylene can lose heat quickly. It loses as a form of radiation losses, infrared light, near infrared light. But it's probably not a big deal, because in this situation you don't heat the greenhouse a lot in this part, so that's good. Now I am also giving you some thickness of the material. Polyethylene is the thinnest of all, and the glass and polycarbonate are about 4 mm thick. Okay. Structural weight, if you are using polyethylene, you want to just go for a light greenhouse structure, medium, and a pretty heavy structure for glass, simply because glass is heavy. Okay. But there are a few things I want you to kind of spend a little time on. If you are going for polyethylene, what we recommend is, definitely in this area you want to add a UV blocker to that material. So they say polyethylene is, in this case, let's say this example, 10 cents per square feet. Okay, very cheap, 10 cents per square feet. But then I go and say, well, I don't want you to give me just standard polyethylene. Please add on UV blocker to it. So it increases the lifespan a little longer. So that increases the price from 10 cents to maybe 20 cents per square feet. We also add in the US an IR blocker. Remember, I just said it has got a really high thermal transmission. It loses heat. But if you put an IR blocker, it holds the heat a little longer. So we may actually add on another IR blocker, so that will probably increase another by 5 cents. So now we are at 25 to 30 cents per square feet. Okay. But usually what you normally see for polyethylene is, especially in colder climates, we say double poly, 2 layers. 2 layers, and in between is what? Air. What does that air do? Insulation. And we are insulating top down or bottom up, no heat transfer is happening. That's what is happening. We go for a double layer. We pump air actually and keep that completely under pressure, right? Double poly. Okay. Here is an example of double polycarbonate. You see there are 2 layers, in between there is air. So the material comes built in like that. You see that there's a gap right there? That's air. Okay. But we recommend for the thermal insulation. Okay. If you are concerned about heating losses, the best is polycarbonate, because it's not going to let any heat out. But it's probably not popular here because you're not really concerned about heating losses. What you're concerned is about cooling issues, right? So that's what it is. Then comes the glass. We have floated glass or tempered glass options. But the most important thing is, I've talked a lot about glass, durability, light transmission, things like that. But there's also another benefit with glass. You see, these are called glass panes. Nowadays, these are about 2 feet by 4 or 2 feet by 8 feet long. But then you put these panes and you connect to the greenhouse. What is the structure that holds the glazing material? I just told you. What is the name of that? It starts with letter P. Purlins. Remember? So you anchor these glass panes onto that purlins. But then when you are doing that, you kind of create some small gaps between two panes. There is always some air gaps. And through those small gaps, that humid air escapes. So what we say in our common language, glass greenhouses, they breathe because air is going in and out. So usually glass greenhouses kind of have low relative humidity. They're a little bit drier, and this will be very useful in the case of a humid region. If you are in a humid region, it can be very humid inside. Glass can actually, simply because of the ventilation, infiltration glass. Okay. But these are the three types of materials, in terms of durability, price, light transmission, thermal transmission, structural weight of the design, and some other considerations. I kind of put them in sort of like a tabular form, so you can kind of differentiate them side by side. Okay. That's my last slide for this greenhouse construction chapter. Just quick review. We started with location details. Then we looked at orientation for single span versus multi-span, how the ridges should be placed. Then we looked at designs of the greenhouses, both for single span and multi-span. I mentioned about different components, their names, rafters, purlins, top ventilation, ridge ventilation, side posts, curtain walls, struts and diagonals, all of that. We looked at two models for multi-span, two models for single span. Then we dived into loads. We talked about dead load, live load, snow load, and wind load. Okay. And I gave you some numbers for each of them that you should keep in mind. When you're looking at these designs, make sure you understand what is the load bearing capacity of structure. And if the load bearing capacity is around 35 to 45 PSF, you're good. Okay, that's going to hold against wind velocities, is going to hold against snow, it's going to hold against any people working on that, all of that. It's also going to hold to the components you hang to the greenhouse, plants or light bars or everything, fans, things like that. And then finally we talked about different glazing materials, what are their advantages and disadvantages. All of this information is meant for you to make an independent decision. Okay, you should not always try to get the best one because your resources may not be there. It may become so expensive for you. But you should at least try to know this information, so then you can actually make your own independent decision on which of this to consider. Okay, that's what this chapter is about. All of this will be available to you, by the way. I know you're writing, that's important, it's good, but you should have received all of this by now. If not, you will receive it very soon. An entire booklet will come to you as a PDF file, okay, for all the chapters, all the lectures, everything. Okay, again, if you have not heard this morning, I made an announcement that I'm not taking the third lecture today. Okay, the third lecture is scheduled at 12 o'clock to 1 o'clock. We're not doing it at 12 o'clock. I have some other personal thing I have to attend to today. But we're going to start the tutorials at 3 o'clock. I think we may just do the third lecture between 3 and 4. That's a very important lecture on hydroponics. Okay, if you want to learn about hydroponics, please do come to that lecture. We'll do between 3 and 4. All right, and then after 4 we'll do the tutorials. I will not be available for the tutorials because they've arranged a faculty meeting in this building with me between 4 and 5, but I'm going to introduce you at least 5 minutes, 10 minutes for the tutorial. And the tutorials is meant for you to sit down, design a greenhouse. All those location considerations and orientations, things like that you learn in this class. I'm going to give you a scenario and you're going to design a greenhouse on that piece of paper. And you're going to explain why you designed it so. Okay? So this chapter is going to be important. If you don't have it, ask one of those students who are helping this whole program to send the PDF of this lecture to you. So you can actually look at that and design a nice greenhouse. So you're going to work in groups or individually, it's up to you. Maybe you spend 1 hour, 1.5 hour, whatever it is, we'll revise that. But between 4 and 5, I'll just have a meeting and then we'll convene at 5 o'clock and we'll just take about 15-20 minutes, look at your greenhouse designs, and then we are done for the day. All right? So a little longer today, and I thank you for that, little longer today.